All right. What would you like to do? Okay. Let's see. Let's go over the schedule for the rest. So we can review anything from the exam 5 study guide, the final exam, and so next time is the exam 5, right? And the Tuesday is the final exam, unless you want to do it in the testing center. So I made it available for you in the testing center. You can take it on Tuesday, that's fine. Your choice. I'll be here on Tuesday for the final. If you want more time, you can have till Thursday in the testing center. Okay, your call. And if you pass the exam 5 and you're good with your score, you don't have to take the final.
So after
Yeah.
Thursday's exam, if we like our grade, that would be our
Yep.
final grade?
Yeah. Okay. All right. Exam 5 study guide. Did you guys go over this? Do you have any questions on it? Yeah.
Can we just do 9 just to
Yeah.
practice it?
You bet. Know how to calculate the pH of an acid with a given volume of an acid that will neutralize with a volume of a base with a given pH of a base. So I know these might be kind of hard to understand. But this is just kind of an example of a problem. So we want to know the pH. Uh-oh. All right, so we want to know, calculate the pH of an acid.
The screen is not connected.
It was, I thought. There it goes. Thank you. We want to know the pH of an acid. If we're given the volume of an acid, so what acid do you want to deal with? Well, in this case, it says it's going to neutralize with a base. So if it's going to neutralize, what kind of acid are we dealing with? Strong acid. Okay, and there's like 6 strong acids, right? So we can deal with HNO3. Let's deal with the more complex one. Let's do H2SO4. And it's not really complex, it's just not a 1-to-1 ratio, right? So let's say we have a volume of, let's see, it says with a given volume, let's say 250 milliliters of H2SO4. And it's going to neutralize with a base. And it's going to be a strong base because it's going to neutralize. So it has to have OH in it. So let's say we have sodium hydroxide, for example. And it has a given pH of this base. So the pH of this base, let's say, and I'm just picking out numbers, so it's not going to be beautiful, but let's say the pH is 12.5. And why do I know it's 12.5? Because it's a base. It's a strong base. So it's going to be closer to 14, right? And anyway, you won't have to worry about that. They'll be giving you all this stuff, yeah? With a volume of the base, so let's say we have 1.5. No, let's keep it simple. Let's say we have 300 milliliters of this base. Okay, so what can we do? So this is our base, and we want to find out about our acid, right? So since we need to know something on our acid, let's start with our base, because we know a lot more about our base. Does that make sense? Start with what we know rather than what we don't know, okay? Okay, so I know that, and I know equations, right? And we have this on our reference sheet. So what can we find here? We possibly can find hydrogen concentration, but this is a base. So we might want to worry about our pOH. Does that make sense? So pOH is equal to 14 minus the pH, or pH plus pOH is 14, right? Does that make sense, guys? Okay. And do you guys have this right now? Have this out so that you can use this to guide what you should do. Okay. All right. So we're going to put in the pH there, which is 12.5, and that's going to give us a pOH of 1.5 pOH, okay? And so from the pOH, this is study guide exam 5, yep. So now that we know the pOH, we can find the what? The hydroxide concentration, right?
Which is 10 to the negative the pH.
Which equals 10 to the negative pOH, right? Good. Which is 10 to the negative 1.5 in this case. Somebody calculate that for me.
3.16 times 10 to the negative 2.
Times 10 to the negative 2. And that's molarity, right? Concentration of OH. All right, great. Now what do I do with that? So that's concentration of OH minus. Convert it to moles. Okay. Almost. We're almost there. What? Okay. If we convert this to liters, this is milliliters of NaOH, not OH. But what do we know? It's a 1-to-1 ratio, right? So to show all of the work, and again, you don't have to if you know this, right? We can see that it's a 1-to-1 ratio. So we can say, okay, this is moles over liters, right? You all with me? And so we know that 1 mole of OH is the same as 1 mole of NaOH because it's a 1-to-1 ratio. You following me? Do you have any questions up to this point? Please say something if you're not sure what I'm doing or why I'm doing what I'm doing. Yeah?
And you have to write the 1 mole of OH and 1
You
mole
don't have to. Because it's a 1-to-1, it's just multiply by 1, divide by 1. It doesn't do anything, right? So if you can see that it's a 1-to-1 ratio, we can just say, okay, this is the same as 3.16 times 10 to the negative 2 moles of NaOH per per 1 liter, right? Yeah, question.
On the exam, will they give us like the formula for us to see what's going on?
Oh, let's see. Well, here's the formula. NaOH is Na plus OH.
No, I mean like, will it have the H2SO4 on there? You know what I mean?
It'll get, oh, you mean the equation?
Yeah, the equation.
It may or may not, but it tells you it neutralizes it. So should we write this? Let's write it. We're going to neutralize these two. So we have sulfuric acid plus sodium hydroxide. What kind of reaction is this? Acid base, double replacement. So we can predict what the products will be. These guys are going to swap places. But in an acid-base reaction, we're always going to get water, right? Plus sodium sulfate. Sodium is Na plus, sulfate is SO4 2 minus, so you cross the charges and it's going to be Na2SO4. Good?
Would there be 3 hydrogen atoms instead of water? Because I know it creates water, but there's 2 from.
Now we just got to balance it. Don't get wrapped up in these numbers yet. Okay? So yeah, there's 2 here. That's because this was a 2 minus, right? So we cross the charges. And now it's over here because the 2 came down to here. Follow? So once we have this, now we can balance it. We better put a 2 right here and probably a 2 right here. Is it balanced? Does that make sense, how to come up with that? So you should be able to do that. That's something, now, that's not what we learned this unit, but you should be able to do that. So I may or may not give you that equation. But can we get there? Now, in this example for number 9, I probably will give it to you. But let's say I didn't. Could you do it? Okay. If it's a neutralization reaction, it has to be a strong acid, strong base. But if I give you this, I'll give you that or give you this. So you just use the double replacement and you predict the products. And then balance it. Good? All right, but do we even need, I guess we will need that eventually, won't we? Yeah, we will. Okay? Does that make sense? Okay. So now that we have this, what do? Like Claire mentioned, let's multiply by the volume, right? To get rid of the liters. But we got to make sure this is in milliliters first, right? So we can do a conversion over here, milliliters to liters. Good? And so that's 0.3. So we can multiply this by 0.3 liters. You following? And now we have moles of NaOH. What are we looking for? The pH of our acid. Okay? So now what do? We can multiply these if you want. 3.16 times 10 to the negative 2 times 0.3, what do we get?
9.48 times 10 to the negative 13.
Try again. Now I want you to realize something here. This is 10 to the negative 2, so this is, if you put it in regular notation, it's that, right? If you times it by 0.3, it's gonna make it smaller, but not 10 to the negative 13 smaller.
9.4 times 10 to the negative 3.
So just pay attention about that. Don't just believe your calculator, because your calculator only does what you tell it to do, and if you make a mistake, it will make a mistake. Okay? I didn't know what the answer was, but I knew it wasn't that small just by looking at the other numbers. Make sense? Okay, so that's that many moles of NaOH. What can we do with that? Yeah, use the mole to mole ratio to convert it to the acid. Perfect, using the balanced equation. And what is the mole to mole ratio? 1 to 2, right? Good. So 2 moles down here of sodium hydroxide to 1 mole of sulfuric acid. That goes away. And we're looking for the pH, so we got to find the concentration of it, right? The H concentration. We have 250 milliliters, so let's convert that to liters. Does anybody know what it is? 0.25. So we're going to divide that by 0.25 liters, and that's going to give us our concentration of our acid. But to find the pH, that's equal to the negative log of the H plus concentration, right? From our equation. So we have the concentration of our acid, but what's the concentration of H plus? Do you want to find an answer there or keep moving? Because you can keep going, or you can find an answer and then move from there. Find an answer, move from there. What do you guys want to do? Keep going? Okay. All right, so now we have moles per liter of our acid. What's the ratio of acid of H2SO4 to H plus? Can you look at this right here and see it? For every one of these, how many H's do we have? 2. You follow? Okay. So we have, for every 1 mole of H2SO4, we have 2 moles of H plus ions. You following? Anybody have any questions up to this point? So that goes away, and now we have moles per liter, or molarity, or concentration of H plus, and that's what we need. Now we can find the answer to this and plug it in here. So somebody calculate that. Tell me what it is.
It's the same as moles of NaOH. Because we took the molar concentration of NaOH, and it was a 1 to 2 ratio, so we divided. Oh no, I didn't multiply by 2.5. I was like,
Yeah, it shouldn't be the same. So these two cancel out. That's okay.
The twos
So
cancel
we
out.
divide it by 0.25. Now, if these were the same volumes, then it would be, but they're not quite. So 9.48 times 10 to the negative 3, divide 2, divide 0.25, multiply 2, and we get what?
3 point. Oh, sorry. Go ahead.
Oh no, I don't know. I got something else, but I don't know if I'm wrong. I'm probably wrong.
I got 0.03792.
0.03,
Yeah.
which is
Or
3.792
792
times 10 to the what? Negative 2? Yeah, just in scientific notation, that's okay. Either one works. So now we do the negative log of that answer, and that's our pH, which is what? 1.42. Okay, my number isn't too bad. according to, I just pick these numbers in my head, so it's, sometimes you get wild numbers, but when you do that. Does that make sense? The process, I mean.
I feel like the homework doesn't, I've been working through it and I'm not like noticing doing the like ion to mole ratio. I don't know if that's just, I don't know.
So the homework doesn't have you do that?
Not that I've noticed, so I'm like nervous to not practice it.
Oh, okay. Let's see. Now, most of the time that we've done it here, it's been a 1-to-1 ratio. And when it's a 1-to-1 ratio, you don't have to worry about it. Then the H plus concentration is the same as the acid concentration. Or the OH is the same as the NOH or whatever. If it's a 1-to-1, but you have to just recognize when it is and when it's not. Can you see that? And then it's just like a mole-to-mole conversion. We don't have to have an equation, it's just right here. H2SO4, for every one of these, we have 2 hydrogens. That's it. And if it's something like, I don't know, MgOH2, it's 2 hydroxides for every 1 magnesium hydroxide. But if we're dealing with lithium hydroxide, well, it's just a 1-to-1 ratio. Or hydrochloric acid, it's just a 1-to-1 ratio. Is that the part you're worried about?
Yeah.
You just, here's the thing. Use dimensional analysis. Show all of your units. Don't skip units. Otherwise, you're gonna mess up somewhere. But if you can see, okay, so this problem, let's go back. We was trying to find the pH of H2SO4, right? And to find the pH, it's negative log of not H2SO4, but H plus. So from here, we gotta find the concentration of that so we can find the concentration of that, which is a 2-to-1 ratio. Does that help or no? I don't know.
It makes sense. I'm just like, why isn't it in the homework? Like, that's what makes me nervous, that it's like not something that's being practiced. And then also the homework was like, it was asking us to do like pH of the concentration of H3O plus. And I don't know if they were using those interchangeable.
Yeah, H3O plus, remember, is the same as H plus.
Okay.
They're the same.
Okay. So that doesn't mean anything different then.
No, because really, remember, H3O is just H plus aqueous. H plus with water, right? That's all it is. And when we're dealing with acids and bases, they're always aqueous. Yeah, so some books like to use H3O plus and some like to use H plus, so.
Are the numbers on our study guide 8 through 11 kind of the same idea because I'm reading them? It's the same, kind of the same, but just asking.
Kind of.
Kind of the same, like.
So you're given the volume. So it's not asking to calculate both of those, it's one or the other. So if you can do one, if you could do both, then we're good, right? It's just, but you just use a different equation. The POH is negative log of OH and pH is the negative log of H. And that's for 8. And then 9 we just did. And then 10, how to calculate the volume of an acid. So let's try to make something that might be useful. I'm not in the habit of using this, so it might take a minute to to put it out of my brain onto paper. Is that okay? So let's see. We have grams of A going to moles of A. Remember this? Oops. Oops. Moles of B, grams of B. And we can kind of make, so this one goes to particles, right? But, okay, but we could even go from moles of A to molarity of A. Okay, so molarity of A, or concentration, I should just write molarity maybe. And what do we use there? How do we go from moles to molarity? Volume, right? And then from there, if we can consider A as the acid and B as the base, that kind of helps, right? So this is the molarity of an acid, which from there, we can calculate the pH, right? Which is negative log of the H plus, or in this case, if it's a 1-to-1 ratio, it's the same as the acid, right? And if it's not, then just multiply or divide by 2, depending on what it is. And we could do the same thing on this side. So molarity of the base and the pOH. But that's not on your reference sheet, so you would have to draw that in, and I don't know if that's useful or not. But this is volume, and this is negative log of the OH concentration. Was there anything else? Yeah.
The homework lady drew this, but instead of like the double arrow that you did between molarity A and pH, it was like molarity A to pH, and then she did another arrow below it pointing to molarity, and that was the 10 to the negative pH.
Oh, okay, yeah.
Because like up there it seems like you could use negative.
Did you like her method?
Yeah, it conceptualized it for me. I was really confused with it.
I should probably get that down. I never use that. Sorry. But okay, I will. Let's see. So can you help me know what it says? So instead of a double arrow,
Oh, to the other one.
oh, this one right here. So it's just an arrow here and an arrow.
And then another, like, parallel arrow, but pointing to the molarity from pH. pH pointing to the molarity.
Oh, like this.
Yeah, and then that bottom arrow represents negative log to the, or not log.
Or
but
10 to the negative
This
pH.
is how she has it in there.
Oh, okay, perfect. Thank you. And then, of course, we can go from pH to pOH, which is pH plus pOH equals 14, right? Same thing here. Oh. Why? Oh my gosh. Oh, there's It's here. It's still here. Sorry. It's like, this guy's crazy. All right. Does that kind of make sense, guys? So maybe if I would have taught you that way and had you using it, huh? I'm sorry. But it doesn't say anywhere to where, so this is the molarity of the acid. But then you'd still have to make sure if it's not a 1-to-1 ratio, you'd have to convert that still.
I think it would be like cool to add a little word about converting it from the H concentration, using that ratio between.
Well, let's see. So if, I don't know if I'm going to be. If anybody has a good idea of what would it really be useful, write it out and make it nice and neat. And maybe I'll just take this one out and put yours in and give you extra credit if I like it.
Wait, can we use it on this test?
Definitely. If you get it to me before we take the test.
Can it have this in it?
Yeah.
Yeah.
Uh-huh. Who's going to do that for me?
I can barely get it, so.
Was this yours?
I'll submit a version. We'll see.
Okay.
Put it on my
A lot. So it has to be before Thursday because I got to make copies of the new one.
But that kind of helps though with the steps.
Yeah.
'Cause I feel like,
Helps you to know
yeah.
how to get there.
Sometimes in the homework, I
Uh-huh.
can understand kind of what I'm doing, but if I get lost, then I literally stare at my paper for 10 minutes trying to see where I'm going next. Having a roadmap is nice.
Okay.
I feel like that's nice.
All right.
I have a homework question. When you're-
All right. Are we okay with those problems though? So a lot of them are real similar, aren't they? So, and you just have to kind of know how to use these guys and, yeah, and what molarity is, yeah. That's in addition to the mole roadmap, yeah.
Could we do buffers?
Yeah. So I'm not gonna give you one that's, an extensive buffer problem, like the one there's one on the worksheet that, like, we're not, that deals with 2 equations, 2 unknowns, and you do a lot of algebra and thing. So we're not gonna do that, but let's see.
Question 79 talks about buffers.
79 on
I'm sorry,
On the final? Okay. All right. So this is number 79 on final study guide. Okay, it says calculate the pH of a buffer by adding given amount of moles of a weak acid and weak base with the known Ka. Okay, so we're looking for pH of our buffer. And what's a buffer solution, guys? Only have a weak acid and a weak base, right? Okay. And anyway, so let's say we have, so given amounts of moles. So you guys know you don't have to have a molarity, right? Because if you have a molarity of a buffer solution has an acid and a base, but it's all one solution, okay? And so if you have a liter of it, well, you have a liter of the acid and a liter of the base. You follow? Or if you have 1.296 liters, a yucky number, then it's the same number. So if, and the equation is right, right here at the bottom, says H plus concentration is equal to Ka times the Ha, which is our acid, our weak acid, and our A minus, which is our weak base, yeah? So we're dividing them, so if we have the molarity, the volume's gonna go anyway. So you can either have molarity or just moles. So in this example, in 79, it says you're given the moles of the weak acid and the weak base. So the weak acid, let's say, is HSO4 minus, okay? And let's say this concentration, or the molarity, let's say we have, let's say we have, and I'm gonna probably pick stupid numbers that don't really work in real life, but okay. Let's just say we have 3 times 10 to the negative 2. No, that's probably not right. Let's say we have 4.9 moles of HSO4 minus. Good? And then if this is our acid, what's our conjugate base? SO4 2 minus, right? And so let's say we have 2.3 moles of that. Okay? And so how do we find the pH? Well, we got to find the H. And let's say our Ka, which is, and again, I don't know what it is. I'm just throwing it out there. So 3.2 times 10 to the negative 3, okay, or something like that. And so then you just plug these values in this equation. And you'll be given all this stuff, so you don't have to try to pick it out like I am, okay? So it's going to be the H plus concentration is going to equal the Ka, which is 3.2 times 10 to the negative 3, multiply the K, the acid, the number of moles of acid, or the molarity. In this case, it doesn't matter. You can use moles or molarity. Do y'all understand that, or do I need to show you that? Okay. 4.9 moles of my HSO4 minus divided by, in fact, we probably don't need to write all that stuff in there. Divided by the 2.3 moles of my conjugate base. And then that's going to give us the H plus concentration, and to find the pH, we just do negative log of the H plus concentration. Does that make sense? Yeah.
When do we use that equation again? I remember using this.
For a weak acid, weak base, a buffer solution. Uh-huh. So when you're not dealing with a strong acid, strong base, it's not going to neutralize. And so you have an acid base in there, and you want to know the pH of that buffer solution.
Got 2.16 for the pH.
And so that's probably wrong, because it's going to be closer to 7, is my guess, if it's weak acid, weak base, but but that's okay. You get the idea? Did that answer your question, Elizabeth?
I
Or
just
Betsy?
forgot what it
We're good then?
Yeah, I think so.
Okay. Yeah,
Can we do the half-lives thing?
yeah, sure can. Let's. Um, I'm just pulling up this worksheet that I found on the internet so that I don't have to make something up in my mind. Sound good? All right. So sometimes you'll be asked to find the half-life. So let's do one of those. So what is a half-life? So half-life, I just like to abbreviate it like T sub 1/2. Good, you could do what you like, but what is the half-life of a 100-gram sample of our nitrogen-16 that decays to 12.5 grams in a total time of 21.6 seconds? Okay. Sorry, I'll be right back. Why don't you guys run it? Was everybody able to go through that video if you wasn't here last time? Okay? All right. All right, so what do we do here? Any ideas?
We start with the 0.
Yeah, that's how I start. At time 0, how much do I have?
100 grams.
100 grams. After 1 half-life, what do I have? 50. We just divide it by 2, right? After 2 half-lives, we have? Divided by 2 again. After 3 half-lives, we have?
12.5.
And we just go until we get that number. So that tells us we have 3 half-lives. We want to know how long 1 half-life is. So what do? This is t. This is t half. You with me? So what do? The total time divided by 3. Does that make sense? So 21.6 divided by 3, 7.2
Yep.
seconds, right? Does that make sense to everybody? Okay. Do you want another type of half-life problem?
Sure. Yes.
Okay. Let me find, let's see. What is a half-life? All right, so another type is we know the half-life is 0.025 seconds. We want to know how long it'll take a 560 gram sample to decay to 1/4 of its original mass. 1/4 of 560, whatever that is.
140.
Okay? Well, so that's 140, you say? Okay. So it's pretty close to the same thing, right? So we start with what we started with is 560. Divide it in half once.
280.
Divide it half again, we're going to get 140, which is 1/4 because we half and a half, 2 halves is 1/4, right? Okay. So how do you find the total time then? Yeah, and this time we know that time. We're going to do it twice, so we just multiply that by 2 and we get 0.05 seconds. Good? No? What's your question?
I don't know, I think it's just determining when I have to divide and when I have to multiply.
So, this is the total time, and this is just 1 half-life. So this is t, and each one of these is t 1/2. Every time you cut it in half, that's 1 half-life. So we cut it in half 2 times, so that's 2 half-lives. So 2 of these is equal to the total time. Make sense?
Yeah.
So don't try to think, okay, when do I multiply, when do I divide? Think about what it is what we're doing. And that's going to help you to, I think, have it click better. Well, that helps me. Okay. Good? Should we try a different type? Let's see if I have a different type here.
This is the problem with learning stuff and then going on break. Going back to it, like, what?
That's why I gave you guys all of the videos. You should have just watched all of them for your break. No. I'm just teasing. I'm just teasing. But I just gave them to you in case you need to do some catch up on anything. So, all right. So let's say the half-life of a certain isotope is 7.04 times 10 to the 8 years. That's a long time. And that's uranium-235 half-life. And
Is that negative
No, that's +8.
+8.
That's like almost 1 billion years. And says 12.5 grams remains after a total time of 2.82 times 10 to the 9 years. How much radioisotope do we start with? So this is our ending value, and this we want to know what we start with. Okay? What can we do if we know both the times?
Can you start from
We can figure out
Find out how many
half-life.
half-lives, how many times we cut it in half, right? So our total time divided by our half-life, and what is that? I can't do that in my head.
why not?
Because it would hurt. Okay.
It's 0.25.
Did you do this number divided by this number?
I did the opposite.
Yeah. Big number divided by small number is going to give you a bigger than 1. Well, these are both big numbers, but
That's 4.
4 half-lives. Okay? So from 0, we're going to go 1, 2, 3, and 4. And after our 4th half-life, the total amount of time is 12.5. Y'all with me? Okay? And so how do we get to here?
Multiply it.
Well, we just do the opposite. We don't cut it in half. We multiply by 2. And one common mistake I get from students is as soon as they get to 1, they think they're done. We get to times 0, our original. So that's not the one. 200 grams. Make sense? What else could you be asked? Oh, how much you end with, right? So you'd be given the same thing. You'd just be given what you started with, and then you just divide it that many times until you get what you end with. Does that make sense? Okay. Other questions? I mean, if you want to do one, I can try to find one.
So, this is going back to kind of what we covered in the beginning. Question number 5 on the final exam. What are the different methods for separating mixtures and state when you use each separate?
Okay. Okay. So remember, let's see, it says, so what are the different types of separation?
There's
Filtration.
filtration
How do we separate by filtration?
with the particle size, right?
Yeah, differences in size, right? Okay. So let's see, what is the different methods of separating? I guess that's one of the methods. Yeah, sorry. That's one of the methods of separating. So what's another method? How do we get, let's say we have an aqueous solution. How do we get this salt out of the water? Boil it. This is distillation. Those are the two main ones. Another common one in your guys' field is centrifugation. I don't know if that's really the word, but you use a centrifuge and that's difference in densities, right?
I think it's called centrifusion.
Centrifusion? Fusion?
Yeah, I think so.
Centrifuge.
I know it's done for blood. I don't know how it's spelled.
Okay,
I think it's, yeah.
okay. That's weird because fusion is putting together. I don't know.
But it's,
Well, something like that. Okay, maybe I should know. I'm a teacher. Huh? Okay. Let's see. I think that should cover you. There's chromatography and
Gel electrophoresis.
yeah. So, I think we're keeping that part simple. shouldn't say I think, I know we are. Okay. Anything else? Yeah.
Okay, could not figure this out on the homework. It's about the acids too.
Okay.
So it says, what's the molarity of an HCl solution if 13 milliliters of HCl solution is titrated with 25.6 milliliters of
20 what?
Sorry, 25.6 milliliters of of 0.1, my brain, 0.130 molarity NaOH solution. And then it gave me the equate.
HCl plus NaOH
Yeah.
gives us H2O plus NaCl.
Yes, thank you. Numbers.
So that's what it wants to know? Okay, so titration. We didn't really talk about titration in here, did we?
If it doesn't come in an exam, you don't have to do it.
But
I was like, what?
But- it's the same thing here, okay? Let's just not talk about what titration is, and okay, let's just. Okay, if we know this, what can we find? If we know molarity and the volume, what can we find? Moles. Once we have moles, we can go from moles of this to moles of this. And once we have moles of this, we have the volume.
Got the molarity. Thank you.
Does that make sense?
Yeah, no, it does. It does.
Okay.
Thank you. I couldn't finish it. Thank you.
So a titration basically is saying it's neutralized. Okay? To neutralize it, you're titrating it. That's just a fancy, icky word. Okay? Sorry, maybe I should have mentioned that. I'll remember that from now on because it's in your homework. Anything else? Do you want to finish this, or you good?
I just wanted to see the steps, but that makes a lot of sense. Thank you.
Okay. Yeah, always start with, how do you know if you start with the acid or the base? Whatever one you have all the information to, right? And then you can convert it to the base or the acid using the mole-to-mole ratio. Okay. What else?
I have one more. If it's
Uh-huh.
okay.
You can have 30 more if you want.
Okay.
I'm here till 9, so.
So it's, what's the pH solution prepared?
What's the what?
pH solution. By allowing 2.65 grams of Na2O to react with
Na2O? Okay.
to react with 750 milliliters of water. No volume change. It's probably easy, but
Hold on a sec.
that's all.
2.65 grams of Na2O.
To react with 750 milliliters of water. Find out the pH.
Na2O.
I know. But yeah, it's
Can I look at that?
Yeah. That was my same exact. Can zoom in.
So this is part B. Does it?
No, I took a picture of it
Oh,
on
okay.
my laptop.
I bet you there's
It
more
wasn't-
information on the. No?
That's
What is the
all.
pH of a solution prepared by allowing to react with? Assume that there are no volume changes. Express your answer using 3 decimal places.
I think he used molarity. I found the. I think he used molarity or something.
Well, that's Oh, okay. All right. So, is this an acid or a base? Doesn't look like either right at the get-go, right? And that's why I was struggling for a minute. Because we was always used to doing simple stuff, right? Okay, so sodium is sodium plus, and oxygen is O2 minus. If you throw this in water, because it's with water, right? Then these dissociate, and you're left with this. Well, what can this do? Accept a proton. So this is our base, right? It's not a strong base. It's a weak base, okay? So we can convert 2.65 grams of Na2O into what? Moles. Good, that's the only thing we can convert to. And sodium is 23 times 2 is 46 plus 16. 61.98. Thank you. Grams of Na2O to 1 mole of Na2O. That goes away. Okay, so we have moles and we have volume.
By the way, sorry, I just, the only thing I had to decide was the reaction, which is Na2O plus H2O equals 2NaOH.
Oh, what's the equation? Say it again.
Sorry, Na2O plus H2O equals 2NaOH.
Oh, there we go.
And because I somehow figured it out, but I just used the mole to mole ratio after that.
Yeah, okay. So convert the mole to mole ratio. So make sure this is balanced. It is, right? Yeah. Okay. Yeah, so we have 1 mole of this to 2 moles of NaOH. And then now we have moles of NaOH. And this is what we're trying to find the pH of, right? When we react these, we want to know the pH of this. That's way better. Okay. So then,
Well, there are 2 moles of Na for every 1 mole of OH you have on there.
2 moles of what?
Of sodium,
For every,
1 mole of hydroxide.
not quite.
But
1 to 1.
it's not really using the hydroxide thing.
Right,
Yeah.
sodium hydroxide is just that.
Right.
So it's just a 1-to-1 ratio. So this is moles, but we need to find the concentration of, and we're going to have to find the concentration of OH, right? So then we can find the POH and then go that method because we don't have H plus, right? And so what's the volume? We know moles, but we got to have concentration. Is this our volume? Yes. It's the only thing we have, but make sure it's in liters, right? So now we can figure our moles per liter, or our molarity, and it's a 1-to-1 ratio of sodium hydroxide to hydroxide. So what's our answer here?
0.114 similarity.
That's the molarity of OH, right? And then we can say, okay, the POH is equal to negative log of my OH concentration, which is 0.114.
It's 0.943.
So the POH is 0. What?
943.
Then to find the pH, it's just 14 minus the POH, which is 13 point something. Make sense? Yeah, if you didn't know that equation, I was thinking about something and I was getting stuck at the same time, so. Yep. Anything else? Okay, so I did tell you guys that you do have the option of taking the final exam, the testing center if you need, up until Thursday.
Yeah.
So that should be set up to schedule if you'd like, if that's what you want to do. You don't have to if you're good with your grade after exam 5, right? Okay, let's rock it. Let's not have to take the final. I'd be okay with that.
Is this our last class?
Yeah. Yep. We learned everything last time and we just reviewed today, so. I can't, I'd have to kill you if I told you. I'm sorry.
It's not the prettiest, but this is what I was thinking about of adding that part in to what she had. So there was some people confused and like, why do that?
Okay. Do you want extra credit for this?
I would say no.
You'd need to put it in like something to where I can, I don't know, maybe that looks good enough.
Yeah, I don't know.
And then just, all right, we'll see. Competition here.
Yeah, I'm just saying.
No, thank you, I appreciate it.
Thanks again.
Thank you, appreciate this. That was kind of it.
Yes.
Thank you.
It's a lemon bread.
Lemon? Ooh. I better not show my wife. She loves that.
Could I grab my cord back?
Oh!
Or do you still need to borrow it for the next
Yeah.
class?
No.
Because if you want to, you can borrow it until the exam if you need one. Because I'll be in class to take the exams.
Gosh. I hate to even do that.
Does it have enough charge for your next class?
No.
Okay. Why don't we plan on that then?
Okay, I'm sorry. Thank you
You're
very
okay.
much.
I've got another cord I can grab, so.
Okay, thanks. I'm just, Laura, I'm just teasing.
If there's one thing about me, obviously you don't know me personally, I'm very not serious person.
Okay.
Not gonna take anything serious, trust me.
Good.
Trust me. Trust me. I don't care. I like it when you joke.
What?
I like it when you joke.
Good.
Some people don't, I'm like,
Lighten up. No.
right? So boring.
Good.